New research from the scientists at the University of East Anglia School of Biological Science suggests that sexual selection improves population genetic health and protects against extinction. Our reporter Emily had an interview with Professor Matthew Gage.
So the question we wanted to tackle was, why is sex so widely used as a method of producing offspring across the planet? So there's probably 8 million multicellular species on our planet, and nearly all of them use sexual reproduction to reproduce offspring. So what we did was we took a small beetle called Tribolium castaneum, a red flower beetle. It's about 3 millimeters long. People might have seen it in the back of their food cupboards. It likes their cereal and the flour. It's a big pest of stored products, but it's also a good model for understanding evolution in action, because it's quite easy to keep. You can set up multiple populations quite cheaply. All they need is flour and yeast and some oats. And it has a generation time of about a month. So every month we get a new generation, so we can evolve 12 generations roughly in a year. It's also quite promiscuous, so there's lots of sexual selection going on at the adult stage in each generation. So we've got sexual selection, we've got it's easy to keep, and we've got a short generation time, so we can evolve it in the lab. So basically what we did was we set up, from the same ancestral population, we set up various regimes where evolution was operating in the laboratory, which only differed in the strength of sexual selection. So in some regimes there were lots of males competing for few females. In other regimes there were lots of females being fertilized by rather few males. And in still other regimes we enforced monogamy and basically removed sexual selection. So every generation we just randomly allocated a male to a female lots of times, and then we just evolved that for about 7 years. We did other things in the meantime, but that was running in the background. About 50 generations of selection, and then at the end of that period we took our regimes, our populations with different backgrounds of sexual selection, and we basically measured how much mutation load sat in those populations. And we measured that by using inbreeding. So when you inbreed a lineage, you expose the mutation load that's in that lineage, because most mutation load sits hidden within the genome. When you inbreed it, you reduce the variability in the genome and you expose mutation load more effectively. So as you inbreed a family, the faster it goes extinct tells you the greater level of mutation load that it carries. So that's all we did. We just took multiple families, hundreds of families, from those high and low histories of sexual selection. We inbred them and we measured how quickly those inbred lines went extinct. And what we found was that if you come from a history of high sexual selection, you resist extinction and you maintain productivity, you maintain population health for a long time. But if you come from a history of low sexual selection or no sexual selection, you go extinct twice as fast. And that tells us that high histories of sexual selection have purged those populations' genomes of mutation load, while histories of low or no sexual selection have allowed that mutation load to sit in the population or even build up in the population. So it tells us that sexual selection is a really important force for purging mutation load out of a population's genome. And perhaps sexual selection is kind of the only process that can do that, because as I said earlier on, natural selection will only work on those genes of very large effect when mutations have happened. And of course, to get sexual selection, you have to produce males and have sex. I don't mean have sex in terms of copulation and mating, I mean have sex in terms of the process of reproduction using sexual reproduction. So that kind of explains why sex exists. Sex allows sexual selection to operate, and sexual selection is a very good tool for a population because it purges that problematic mutation load out of it and allows it to resist extinction and flourish.
This research was funded by the Natural Environment Research Council, the Live Home Trust, and the University of East Anglia. It was published in the journal Nature.